This is a difficulty rating. Level 90 of 100, 7 attempts.
Not a guess. 150 simulated playthroughs, an exact solver underneath, 4 sessions of calibration.
A person played level 90 34 times. They never finished it once.
Nothing here was measured carelessly. Every number was checked against another number.
That was the problem. Here's a project where the instrument was wrong more often than the thing it measured. Empty folder. Bus tourist craze.
Quick disclosure, we didn't build this, and neither of us has ever been to Canada.
We teach 7-year-olds about money on a different channel.
There's a human in this story. You won't see them. They're the cursor.
The brief was a document. It had everything a 100-level game needs except the game. Here's what exists.
A rules engine with no screen, no clock, and no input. The same code runs in a browser, a phone shell, and a server that rechecks your moves.
A solver that proves a level can be finished. A generator that builds the car park backwards, so a gridlocked one can't be made.
100 levels, 1 per leg from Vancouver Airport to Parliament Hill. 100 destination cards, drawn by a second model.
A route map, a windscreen, a briefing, settings, 90 commits, 14 merge pull requests, 60 tests.
9 sessions across 8 days. And it's on a Raspberry Pi, so testers can open it on a phone.
And every one of those levels carries a number saying how hard it is.
That number was re-theorized 3 times. The game a player meets changed far less than the machinery behind it.
One person has played it. The person who commissioned it.
One thing before the rest, because it's the part that transfers.
There were 2 instruments, an exact solver for small levels, a sampler for the big ones.
They were checked against each other, disagreed, and after a real bug was fixed they agreed to within 3%.
That's a genuine result, and it proves nothing, because both of them are the same imaginary player.
A player with perfect recall of a 13 tourist queue, who never mistaps, and never forgets what they were planning 2 moves ago.
Agreement between 2 models is not evidence.
So when your 2 measurements agree, that isn't the finish. Ask whether either of them has ever met the thing. Stage 1. Build the car park backwards. Every bus goes down only where it already has a clear way out.
So putting them down in reverse is always a legal way to empty it. An unfinishable level becomes impossible to make. Stage 2. Try to cheat it. 2 robot players, 1 counts the wheel, 1 reads the queue, and matches bus sizes to groups.
If the obvious trick clears the level more than a quarter of the time, it's thrown away however hard it measures. Stage 3. Small levels are solved exactly. Every state. No sampling. A closed form chance of clearing.
Big ones can't be. 20 buses blew past 2 million states, so above 12 it plays the level a few hundred times and counts. Stage 4. Multiply by a number that came from a person, because the model isn't one.
That multiplier is the only place in the pipeline where reality gets in. It rests on 3 observations. Stage 5. Generate 200 candidates, screen them cheaply, verify the best 8 properly, keep the closest to target.
In real attempts, not the model's units. Those are different scales, and choosing in the wrong one picks the wrong level. Stage 6, somebody plays it.
That stage was added last, and it overturned something in every session it ran. The whole stack, in 1 frame.
TypeScript for the engine and the solver, a dev server and a test runner, a second model for the artwork, a Pi so testers can reach it.
And 1 row that isn't a tool.
5 lessons. This is the one.
The model rated level 90 at 7 attempts. The person gave up at 34. So the correction was 5 times, and it was written down as 5 times.
Then 11 shorter levels were built and played. On those, the same model ran twice as pessimistic as the person, who beat it outright on several.
5 times then half. Same model, same player, opposite directions.
The difference was length. Level 90 had 742 tourists in it. The short ones had 160.
A long level throws away 10 minutes every time you fail, so you can't recall what you already tried. A short one you just play again.
Length doesn't make the decisions harder. It makes learning harder. And the modeled player has nothing to learn with.
Whatever your model leaves out doesn't come back as an error. It comes back as a number that's confidently wrong, in a direction you can't predict. Lesson 2. 11 levels shipped. 3 of them were never cleared once, in 150 plays at any skill level.
Those 3 carried the friendliest difficulty scores in the batch.
When the sampler came back with no clears at all, it fell back to a cheaper estimate, instead of reporting the failure.
So the levels nothing could finish got the kindest numbers. Both of the ones the person abandoned were in that group.
0 out of 150 isn't missing data, it's a fact. The clear rate is under 1 in 150.
The fallback was for screening, where being wrong is cheap. It stood in for the verification, where being wrong is the whole cost. Lesson 3. And it happened 3 times in one project.
An attempt counter recorded play against level numbers, and the levels were regenerated twice underneath it, 3 puzzles pooled into one row.
A set of structural checks sat below a branch that only ran on small levels, so they quietly skipped most of what they guarded.
And the script that generates the artwork printed. Every leg already has a card, nothing to generate. 94 were missing. It exited 0.
That one was 2 things. The package runner ate one of its own flags, and this machine ships a shell from 2007 that can't read a list.
Every one of those reported success. Not one could tell nothing wrong from nothing examined.
That difference isn't automatic. If you want to check to know which of the 2 it found, you have to write the difference in.
Lesson 4. Early on, a rule was measured. Past about 2 colors for every depot bay, the puzzle stops being playable.
It was correct. It was written down in the project's own record with the numbers beside it.
89 of the 100 shipped levels broke it.
And nothing went wrong in between. A gate added later needed more colors to stop levels being cheatable, and nothing pushed back on the bay count.
2 locally sensible rules combined into an unplayable one, and the finding that would have caught it was sitting in a document.
It's a limit in the code now, with a test. So are the other 3 rules here that had been prose first.
A document can't reject a candidate. If a finding matters, it has to become a check, a test, or something that fails. Otherwise, it's decoration.
Lesson 5, and this one is about who was wrong.
The player asked why the queue's entrance and its exit sat next to each other on the wheel, which made the board hard to read.
The agent answered that moving them would change whether every level was still solvable, and reopen weeks of difficulty work.
That was accepted. 2 rounds then went on animating around a constraint nobody had tested.
Asked again, it measured instead. The same dispatch sequences replayed through both layouts across all 100 levels.
5,783 dispatches, 0 differences. It was free, and it had been free the whole time.
It sounded like the kind of thing that's obviously true. The check was 1 script and 10 minutes.
And the measurement lied twice first. 2 runs of mismatches that were the test's own fault, either of which would have confirmed the wrong answer.
The one that agrees with you is the one to run again.
3 more, quickly.
1. A whole session was built on a checkout 2 merged pull requests behind. The project's own record read as current and was stale.
A defect diagnosed, a fix designed, a decision escalated to the human on a false premise, and 90 minutes regenerating levels against dead targets.
Every step of it was sound. Local coherence is not evidence of a current premise. Fetch before you read your notes, not before you push.
2. The windscreen nearly shipped a personal best that can never move. A win means every bus dispatched, and 1 dispatch is 1 move.
So the best score is the bus count on your first clear forever. 1 question caught it before anyone saw it. What would this look like on a second run?
3. A scripted find and replace matched nothing, silently, while the edit beside it worked. A whole run was spent before a grep found the old values.
It happened twice here. A silent no-op is worse than a crash, and it's the default behavior of most scripted edits. So that's the build. Here's what it isn't yet.
The correction between the model and a person rests on 3 observations. 1 was taken before the 0 clear bug was found, and may itself be bad.
and the whole chapter has been played by one person, who commissioned it, and who can see every level's difficulty score.
It's on a Raspberry Pi now, with a note asking 4 questions. The first is, where did you get stuck or bored, and which leg?
There is a difficulty distribution, a calibration curve, and one player.
We come back to this when the testers have said something, including the parts of this one that turn out to be wrong.
Which, based on the last 9 minutes, will be some of them.
It's all in the description, the repo, the write-up, the difficulty pipeline.
The write-up is 2,800 lines, and about half of it is corrections. It's the best part.
Next folder's already empty.